I want us to deal with the cone. Cone, what is it? When we talk about the cone, we are referring to a solid figure that has a cylinder face. That's a cylinder face on one end. That's a cylinder face on one end. Alright? Called the base. So you know what a cylinder is? It has a circle at one end and the other end is so a circle, which are equal. So it's a cylinder. But here it is only one end that is like a circle, but the other end is pointed. Okay? And when that happens, then we call it what? A cone. And a point at the other end where the sides meet, which is what I just described. Some examples are finials, Christmas, heart, and eye. So let me just give you an example. So we have the Christmas tree. You can see how it is forming. You call it a cone. It's a cone. And ice cream is a perfect example of a cone. And plain top is an example. And we can illustrate as this. So the down here is forming a circle. That's why we say that it is like a cylinder with one side, but the other side is pointed. Now the top here is what we call the apex. And we have the slanted height. The slanted height, then we have the base, which is what we just talked about. It's a circle. So we have, if you have one of these circles on top and you join them, you form a cylinder. But here's the case, you only have one base and we have it apexing. Now we have the height and then the base radius. So this is the part of a cone. Okay. Now the base radius of a cone. So we need to consider the sector below. This is a circle and this is a sector cut out of the circle. When I cut it out and pick it out as this, we can fold it to now form what? A cone. We want to derive the formula of the finding the area of a cone from the circle. Okay, because we know what a circumference is, which is 2 pi r. Then we know what the formula for finding the area of a circle, which is pi r squared. So using that, we can be able to deal with the cone successfully. So the relationship between the radius of a circle and the base radius of the cone is that we have, this is a circle, right? And this is the radius of this circle, labeled with a big R. OB is the radius of the circle. The length of arc AB is equal to the circumference of the base of a cone. The length here is equal to the circumference of the cone. Remember, when we folded it, we will get the cone. We fold this, we get a cone. And once you fold it, the AB forms a circle under. Try to picture it there. And then the formula for finding the circumference of a circle is 2 pi r, like I made mention. Then the length of arc AB is the angle here divided by 360, because the total angles of the circle is 360. So we pick this divided by 360 times 2 pi r, and 2 pi r is the circumference of the circle, where r is the radius, and here the radius is labeled as capital R. That's why we have the capital R here. All right. Now we can cut out that place, and we still have the arc forming here, AB, and then we have the radius OA and OB. We can fold this to form a cone, and once it's formed a cone, we have a new height and a new radius. So the AB here has formed a circle down, and we have a new radius for it. So the big R here, remember when you fold it, it has become the slanted height, which is the L, and the small radius has become the base radius of the cone. So these are the two different radius that we have after you have taken this and you have formed the cone with it. So now it implies that if the area of the length of AB is beta over 360 times 2 pi r, which is equal to the circle here, it means that if you are finding the circumference of the base area, the base circle here, you are going to get beta over 360 times 2 pi r, which is this, is equal to 2 pi r, the whole base circle. That is this small r. That's the relationship here. So this length AB is equal to the whole of the base circumference here. Now the base radius of a cone, which is what we have just illustrated, to calculate the base radius of a cone, make r the subject in the equation above. So you will find the small r. So you have to make the small r the subject by dividing through by 2 pi. So if I divide here by 2 pi, then divide it by 2 pi, then it means that 2 pi and 2 pi goes away, then 2 pi and 2 pi also go away, leaving r, implying that we have the beta over 360 times r, because this one has gone, leaving only r, which is equal to this also goes, leaving the small r. Now implying beta times r is beta r over 360 is equal to the small r. So anywhere you find the base radius, you can just code this formula and you can easily get it. So the base radius is this small r we have found. Okay, all right, and easily as you can imagine, the slanted height here is the big R, and then the whole of this is the angle here. All right, now finding the curved surface area of a cone, the sector of the circle is also known as the curved surface of the cone, and the net of the cone as well. So the sector of the cone, like the one we just made mention, like this. All right, the curved surface area, if you find the area of this, is the curved surface area for the net of a cone. Thus the curved surface area is the same as the area of the sector. Area of the sector is this, beta over 360 times pi r square, and the r here is the big R. So if you find the curved surface area of a cone, you can just code this formula, you are good to go. Therefore the curved surface area of a cone is beta over 360 times pi r squared, which is equal to beta times r. So we are just splitting the r here, so r times r is r squared, just splitting it. We are trying to find something here. Now we know, remember the previous one, we have dealt with this already. The base radius is equal to beta r over 360 degree, right? So we can replace it with this, then we can have r. We have replaced this one with the small r. Now we have pi r, then a small r. That's why we have this. So anytime they ask you to find the curved surface area of a cone, you can just code this pi r, the big R, or pi r L, because when you fold it, the big R here becomes the slanted height, which is just what I've quoted here. So r is the radius of the circle, the slant height of the cone. Okay, so we got to take one example and we are good to go. So let's get into it and off. So let's take one example and we delve into it. So the question is saying that a sector of angle 130 degree is removed from a thin circle sheet of radius 40 centimeters. It is then folded with the straight edges coinciding to form a right circular cone. Calculate I, the base radius, correct to two significant figures. So we want to deal with that one first. But then the second II is saying that calculate the total surface area of the cone, and the last one is the height of the cone. So let's deal with the first one, the base radius correct to two significant figures. Now, solution, we have this is a circle, with a circular sheet drawn, right? Then the sector is this, and the angle formed is 130 degree. The angle formed is 130 degree. Now the radius r is 40 centimeters. Again, now this sector is cut out and folded to form a cone. So it has been carved out to form a cone. Now remember, this is the radius of the circle, and the radius of the circle has become the slanted height of the cone, because you have folded it this way, and then AB, the arc AB has become the base circle here. Now a new radius has been formed and a height, and the question is asking us to find the base radius, which is this small r. Okay, so with that we can go in. The angle B, that's beta Rory. The beta is the 130 degree. Radius of the circular seat is 4r, which is a capital R, is equal to 40 centimeters. Therefore, the base radius r is given as r equal to beta r over 360 degree, which is what we have derived in the previous slide. Now, once we have gotten this, I can just put in the figure, substitute inside, and you get your answer. So beta is the angle, which is 130, and the capital R is the radius of the circle. Okay, divide by 360, which is the total angle for a circle, and this gives me 14.4. Then that's running it to the two decimal place will give me two significant figures, rather will give me 1.4 centimeters. That's 14 centimeters. Now the total surface area of the cone, if the cone is a solid cone or has a base, then the total area of a solid cone or a cone whose base is covered is equal to the curved surface area plus the area of the base. Now remember, if the base is opened, and it's not covered, it means that the area will only be the curved surface area. But if it is closed, then we find the area of the base, which is usually the circle. The base, remember, the base of a cone is a circle. Now this implies that the total surface area of a solid cone is equal to the curved surface area, which is beta over 360 times pi r squared, which we find in the previous one, we simplified as pi r, the capital R. The R here is the base radius, plus the area of the base is a circle. The base is a circle, right? So pi r squared. So anytime they ask to find the total surface area of a solid cone, then this is the formula you're going to use. If it is specified that the base is opened, then this one is not there because there's no circle to add. So you only have the curved surface area, just like this. So if the base here is covered, so the base here is a circle, so that's the formula for the circle here. So you find the area of the base and then the area of the curve surface, and then you add them together. Now remember, when they talk about the total surface area, it means that find the area of everything in the figure and you add them together, and then you'll be able to go. This is the curve surface. This is a curve surface. This is what is folded to get this. So if you find the curve surface, it's only this. All right. And the base is a circle. So you find this plus this to get the total surface area. But if the base area is not requested for, that is, they say that the base is opened, it is opened, therefore you don't need to calculate this. Okay, now if I'm adding the curved surface area plus the base of the circle here, then I'll get the total surface area for the cone. Now to continue, the total surface area of a solid cone is equal to the curved surface area plus the area of the base. So we are going to solve the II of our question. the total surface area of a solid cone is equal to this. And then recall from our question, we realize that the big R was 40 centimeters. The big R is the radius for the circle where the sector was carved out, and the pi is 22 over 7. That is the pi. If it is given to you in the question, you will have to use that one. Okay, mostly it's given to you as 3.142, so you can use that one to do it. And the base radius we have found correct to two significant figures is 14 centimeters. Man, remember, if you are continue working and you are doing the calculator, it's good to still leave it in the decimal form to use it to work. If you are working with a calculator to get the other subsequent answers, it's good. This one, they say to round it, but when you are solving it, leave it in the decimal place in your calculator and find it. Now, the curved surface area is this. So let's find the curved surface area of that cone before we get the base area. So the curved surface area is equal to pi, and pi is 22 over 7 times 14 centimeters. This 14 here is the base radius, times 40, which is the big R here, the radius of the circle where the sector was carved out. And when you do your algorithm very well, you are going to get this as the answer for the curved surface area. Now, if they say that the cone, the base is opened, you only present this as your total surface area. But if it is closed, then you have to find the area of that circle, which is the base area, which is pi r squared, because the circle, pi r squared is the area of a circle. And you do the substitution and you get the answer as 616 centimeters squared. Remember, the unit of area is always in squared. If you find the area without putting the squared, they will mark you down because it's not a area. Why is it so? If you have forgotten CRA, but we have the centimeters times centimeters, that will give you centimeters squared. You can remember that. If it's a volume, we have height inside. So we have centimeters times centimeters times centimeters. That will give you cube. So volume is always in cube, and then area is always in square. Area of anything is always in what? Square. Square unit. So if there's no unit right there, square unit. So therefore, the total surface area of the solid cone is the curved surface area, which is 1,760 centimeters squared plus 616 centimeters squared. And finally, we give you 2,376 centimeters squared. So we have answered the second part of the question. Now, we continue. They're supposed to find the height of the cone. Now, remember, we have folded it and slant the radius of the sector has now become the slanted height of the cone, which is the 40 centimeters. Now the arc, which AB, has been folded to form a circle, and therefore we have a new radius, a small r, which was found to get 14 centimeters. Now we are looking for the height of the cone, the h. Now we can pick this out. Okay, we can pick this small out, and we can use the Pythagorean theorem to go about it. So from the Pythagorean theorem, the longer side, the hypotenuse, is equal to the sum of the two sides. So we have the h squared plus r squared. The r here is what? The radius, the base radius. So that's what we have labeled as 14 centimeters. And therefore, making h here the subject, you will have h to be equal to the root of l squared minus r squared. That is, yes, if you take this r across the equal sign, you get l squared minus r squared. Then you take the root on both sides to remove the square from the h. Right? Now you can now do the substitution. L is 40 centimeters, which is the big R that was here, the same as the L. And then we have the base radius, which is R, 14 centimeters. Then you square it, implying that 40 squares is 1,600 minus 14 squared is 196, and that was going to give me 1404 if you subtract it. And you take the root of this, you're going to get 37.4699 centimeters. You can use this figure to be working with the other questions you may get. So therefore, the height of the cone is 37 centimeters to the nearest centimeters, right? Or to two significant figures. Now, we want to find the volume of a cone. Finding the volume of a cone. To get the volume of a cone, we must understand what volume is. So from a lot of experiments, the volume of a cone is 1/3 of that of a cylinder of the same height and radius. So if you have a cylinder with the same height and the same radius of a cone, it means that the cone volume of the cone is 1/3 of that of the cylinder. That is what we are trying to say here. And the volume of a cylinder is equal to the area of the base times height. Base area times height. So just keep this in mind that most of the solid figures we are dealing with, if they ask to find the volume, find the base area and multiply by the height. If it's a cuboid, if it's a cube, find the base area. A cube, the base area is a square, so find base area times height. Okay, if it's a cuboid, find the base area times height. That's why you have the length times breadth times width. And then in the square or the cube, or yeah, you have the same thing over there. Now, area of the base is pi r squared because the area of a cylinder is a circle. So we have pi r squared. And the height h. So therefore we have volume of a cylinder to be equal to pi r squared h, base area times height. Now, if you have gotten the volume of a cylinder, we said 1/3 of these will give me the volume of a cone. So 1/3 of that will give me the volume of a cone is equal to 1/3 of pi r squared h. Remember, volume of a cylinder is pi r squared h. Volume of a cone is 1/3 of pi r squared h. Then you are good to go. Now let's look at some terminologies. The volume of solids. The amount of space occupied by a three-dimensional figure is the volume of that figure. Okay, the amount of space occupied by it. The space enclosed by a solid figure is called its volume. Volume is measured in cubic unit. I made mention it earlier on. So the volume of a cone is 1/3 times pi r squared h. Take note, and that's what we are going to be dealing with. Let's get this example. It's a continuation from the previous video. So if you have not watched the other video, you can just go to my channel right now and then you can take a look at it. But let's solve this example. We are finding the volume here. Now, a sector of an angle 130 degree is removed from a thin circular sheet of radius 40 centimeters. It is then folded with the straight edges coinciding to form a right circular cone. Calculate the base radius correct to two significant figures. Then the semi-vertical angle, the volume in centimeters cubed to two significant figures. And then you take pi to be 3.142. Let's get into it. Now this is a circle, and the description here is that a sector AB has been carved out, and the angle from the angle of sector is 130 degrees. Now the radius of this circle is 40 centimeters from the question. So you have to digest the question into a figurative form, then you can start solving it. Now this one is taken out and folded, this part. So AB folded to form this cone. So the arc AB has become the base circle here. And then the radius R in the circle has become the slanted height. Alright. And now they are saying that after this has been formed, You can see another angle formed here, the vertical angle formed here. And that's what the II is asking us to find. Now we get solution. Angle beta is 130 degree. The radius of the circular seat, that is the capital R, the circle, is 40 centimeters. So base radius R is given as R equal to the angle times the big R over 360. Okay, like I said, you can watch my previous video to get how we got the R. Now, just finding the R, do substitution, and your R is equal to 14.4 centimeters. Please, if you like the video, don't forget to hit on that like button and the subscription button, and more to the point, the notification bell, so that when I release any other new video, you will not be left out. Just to continue, that the base radius is 14 centimeters to the nearest two significant figures. Now we get the cone out from what we have just gotten. So I want to draw the cone over here, drawing it. So the base radius is this and the height is this, right? So we want to find the II. The II says we to find the semi-vertical angle, which is the angle here. Now we already know R. We want to find this. So from the trigonometric rule, which can also be applied in the Pythagorean theorem, we can say that sine of theta is equal to opposite over adjacent, looking at where the thing is, right? Looking at where the angle is. So we can easily digest it very well. So we can simplify it taking the inverse of sine. It means that A is equal to 21 degree. That's why alpha is equal to 21 degree. Therefore, the vertical angle is equal to 21 degree. So we have already solved the II. All right, we have already solved the II. Now, the last part of the question asks us to find the volume of the cone. And we remember the volume of a cone is given as 1/3 of the area of a cylinder, which is 1/3 pi r squared h. We need to find the h before we can get the volume, because we already know small r to be 14. We know the slanted height, but we don't know the main height that we are going to use. So from the Pythagorean theorem, we can find the h here. And h is equal to h squared is equal to 40 squared. Just do substitution, 40 squared minus 14.4 centimeters squared. So that this 14 squared, it means that now this minus that will give me this. So we now take the root on both sides to get only h, which is equal to 37.3. Take note of that. So the height is 37.3 centimeters. We can now substitute that inside the formula 1/3 pi r squared h. So the volume is equal to 1/3 times pi. And the question, they say we should use pi as 33.142. So that's what we have just changed it here. Times the base radius, which is 14.4 centimeters squared, times 37.3, which is the height we just found. And this is finally equal to 8,100.629 centimeters cube. So the unit is supposed to be there. Don't forget to put the unit, okay, at the latter part. And then we set to correct it to the nearest centimeters. And that is how we have this. So calculating for the volume of a cube, a cone, should not be something difficult for us to do. And please, if the video has blessed you, don't forget to leave a comment so that I can improve upon it. Subscribe and share, and don't forget to like so that YouTube can promote my videos to a lot of audience.